displays, and the blockchain. Anything else we want to? Okay. So I'm really excited to introduce Jules. He's the CEO and founder of OTOY. He's also a longtime GTC contributor and an advocate for advancing computer graphic technologies. I'm really interested to see, hopefully you are too, how all of these technologies are going to change the media and entertainment landscape over the next decade. Welcome, Jules.
Thank you so much. Hi, everyone. It is a pleasure to be here. For those that don't know about OTOY, my company, our mission is to democratize content creation tools and pioneer technology related to rendering, anything related to the artist workflow, really. And of course, we're a GPU-centric company. That's why GTC is so important to us. I've been doing these GTC talks now. I think this is my 15th in a row, which is pretty crazy. Going back 10 or 11 years, I announced sort of our cloud service with Jensen on stage. And the last time I did one of these in person was 5 years ago. It was 2019. And actually, that was at SIGGRAPH. But that was the last year that we had a GTC. And it's amazing to be back here in the flesh and to have taken really the last 5 years of progress that we've had in our industry. It's interesting also to look at the predictions that we were making even back then. I started doing those predictions in my first GTC. What were we doing in 2010? Where is GPU rendering going? And at the time when we first released our GPU render Octane, images on the GPU were a big deal. Then animations. I have to remember back in those days, it was not a sure thing that you could do production rendering on a GPU. I remember around 2014 or 2015, that was when Jensen had already put us on stage. We were talking about doing movies with Octane. And I sort of predicted by the end of the decade, we'd end up with something that would be close to real time and a bunch of AI. And I think that was 2020. That was 4 years ago. I think that turned out to be pretty accurate. And it is hard to predict where things are going. But I will say that while rendering seems to be on a trajectory that is well understood, I think with AI, we're entering a whole new phase. And Jensen made a point in one of his talks that he thinks that you're not going to be ray tracing. You're going to be doing neural rendering. And given the progress that the industry has made, even that we've made in the last year, and to seeing how fast things are moving, I think it's very likely that you're going to see the future be defined by both ray tracing and neural rendering, and who knows how those two will mix. I mean, part of what this talk is about is to explore that fully and to think about it artistically, philosophically, technically. There are, of course, major things just happening in hardware. We have my iPhone 15 is as fast as a high-end NVIDIA card from 10 years ago. That trend seems to continue. Obviously, on the cloud, though, things are in a whole different world. I mean, I remember when I was on stage with Jensen the year before that, there was no GPUs on the cloud. It was a struggle to get Amazon or Google or anyone to consider really doing that, and that changed about a decade ago. And so looking towards 2030, and of course, we're now 4 years into this decade, I sort of predicted a bunch of different things happening. And one of them was unlimited data. In other words, being able to stream data, not just from SSDs like you do in Nanite, but also just from high bandwidth interconnects. Also neural rendering. I mean, I just figured that there's enough stuff going on with NERFs. Of course, now you have things like Gaussian splats, but just having neural objects, which I'll be talking about in a bit, as primitives versus meshes or volumes or VDBs or SDFs, feels like that's going to be a really important factor. And it's kind of a mid-decade thing, right? And then I had also figured that Web3, I mean, in other words, permissionless, trustless computing, being able to source where data comes from and how operations work, that actually does matter more with AI now, where you want to know where things came from, how they're composed. And then lastly, and this is one of my favorites, holographic displays. So we invested in a company called Lightfield Labs. I'll be talking about them in a little bit. And I do think that you have the Apple Vision Pro, which is an amazing device that came out just recently, a month and a half ago. But the truth is, if you can get spatial experiences that don't require anything on your face, that's the future. So let's explore that.
Things that we
Are you hearing audio?
At the holodeck. What kinds of things can you imagine that are partway there that could be much better than the 3-window iChat that we might see in the next 5 or 10 years?
Well, I don't think Steve's going to announce his transporter.
I want Star Trek. Just give me Star Trek.
That was 2005. And they went on to talk about how there would be all sorts of different evolutions of things. And of course, Bill Gates invested in Light Field Lab. He's actually one of the investors in this holographic company. And I do think that the Star Trek holodeck holds this interesting, it means something to everyone that's involved in it, but it's been a goal for the entire industry. Like, what does it mean to have that thing built? Not just in hardware. There's a lot of deeper things going on with that. I want to show another video.
Once you go into a holodeck, into a virtual world, you would like it. You would like this world to behave according to the laws of physics. If you touch something, you would like to know you've touched it. If you drop something, it should fall to the ground. If you lift something, it should seem heavy unless you don't want it to be heavy. It should obey the laws of physics.
And that's
This
the
has
thing,
been a dream of
holodeck is a
ours
simulator.
since the beginning of computer graphics. We've been pursuing this dream for a very, very long time. And today we've taken a very giant step.
That was 2020. So this is Jensen talking about the holodecks, and there is, of course, the NVIDIA holodeck, which is a collaborative simulator, but the holodeck itself is really sort of a riff on the simulation theory. If you're living your life, whether it's virtual or real or all the talk of digital twins, right? The entire story of Star Trek was premised on the fact that actually in one of the seasons, one of the last episodes, turns out the entire show you were watching turns out to be a holodeck simulation, right? And that is, of course, a riff and play on the fact that maybe we are living in a simulation. How would we know if reality is simulated so well and so correctly, and probably even enhanced by AI? How would we know? And the thing is, it's not even about whether we are living in a simulation. It's what do our lives look like on the other side of that, especially when we have machine intelligence that could be driving a huge amount of work and procedural generation that we would never have been able to do as humans. And it's something that, of course, is in the Star Trek lore, it happens all the time. Holodecks all the way down, just like turtles all the way down. So NVIDIA has a contest called Real or Rendered, and it's something that when you look at, this is our work, by the way, so as we're rebuilding the world of Star Trek, and that is a project we're doing for Paramount, there is this sense of, is the story that we're telling, is the actual, future episodes of Star Trek, are they going to be delivered holographically? Are we going to experience it in a holodeck in 4 or 5 years? And I think so. I think that that's one of the reasons why all the work that we're doing is about building a spatial pipeline. And the Vision Pro is one of the first endpoints where you can experience any of this without a holodeck. But there's a lot of thinking around what this all means. And of course, you have everyone from the New York Times, NVIDIA, we were looking at Jensen. But there is somebody else in this space that is also obsessed with the holodeck, and rightly so, and that is Sam Altman. And he was giving an interview to Time Magazine talking about where he sees things going, and of course, the holodeck came up, Star Trek came up. So there is this interesting intersection between the simulation theory that you could simulate in a digital twin or digital world and what OpenAI is doing. And I think that the reason why I want to focus on OpenAI is that they've done something pretty remarkable with Sora. I have not seen stuff that's comparable to that yet. And of course, it's not even released yet, but you have Variety doing it. Of course, Variety's in the film business, right? They're doing an analysis. 60% of people can't tell the difference between a Sora video and a real video. The one that's highest ranking is this one. I think it's the Big Sur one. And so this is not rendered. This is not ray traced. This is neurally rendered. What is going on here? What is happening in this video? And it turns out from at least what OpenAI has disclosed that it's all just training. You feed this thing more data, and you're getting back a quiescent render. Now, granted, there are flaws in this. I mean, it's not perfect, but I think it's so good that it shows something really important, something that we've seen in some of our own work, which I'll talk about in a little bit. So if you take one of these videos, right, you take this one, which is the Sora video, and you feed it back into something like Luma, which gives you back a NERF, which is what I'm doing here. Well, look, it's a 3D object. It's actually pretty coherent. So inside of latent space, in Sora, and in any highly trained model, you have a 3D object. You have a 3D scene. Now, can you ray trace into it? Do you have to turn that into something else, like a NERF or a mesh or a splat? That's the question. I think that the best version of this data is tracing somehow into latent space. And that's one of the reasons why I put on our roadmap neural rendering, right? Neural rendering, of course, we can generate something that's trained on just images. I mean, that's what NERFs are, right? But ray tracing into that space is what we want to do. It's actually, I think, the best possible version of all these 3D mesh generators that are doing these multiple steps, and you're losing a lot of that quality. And SOAR is probably a good indicator that you're never going to get as good a nerf out of what SOAR is giving you as what SOAR is internally generating. And I came to this conclusion from our own work. This is some of the work we're doing with neural rendering. I'll play this again.
Where are the crew of the Stargate?
Pretty good. We're de-aging Patrick Stewart, and it is a full head replacement, right? This is a test. It's not for a production. It was just us testing a lot of the stuff we're doing with trained data from meshes, from light stage data, which we've had for 15 years. And this is off of footage that came off the show. It's Picard season 2, I think. And this is one modality. This is really high quality stuff. And there is a latent space model of that head. There's also a mesh. There are all these different versions of it. But as we're doing, the whole point of this technology was we don't have to do marker tracking anymore. We can just basically get rid of dots. We can take video footage and treat it as mocap. This is taking makeup transfer from both a physical 3D print of Captain Pike's scarred face, which is one of the things in the Star Trek story, applying it to actor Anson Mount. You can see in the bottom left there is his face without the makeup. It looks absolutely amazing. This is not a super high quality screen, but it renders at 4K. The idea, of course, of videos being real or fake is really important when it comes to people. In fact, when I'll be showing the Star Trek project in a little bit, we did an actor, Lawrence Selleck, playing Spock, and we did it all in makeup and a little bit of digital. And people were confused. People actually thought, oh, your version of Spock, we put out a side-by-side of Leonard Nimoy and him. And the Nimoy estate, by the way, is involved, and they're signing off on all the things we're doing. And they got it wrong. They thought that the Leonard Nimoy was the guy on the left instead of the guy on the right. And so your memories and everything are tricky. It's really important to document and to figure out how to use this technology responsibly. And what I'm going to show next is probably one of the better results out of all of this latent space rendering. It's a head, but this is rendering full CG head in 6K. We didn't have this working until late last year, and it looks pretty good. I don't know how, it's not a 6K display that you're seeing here, but that's Lawrence, our Spock actor, that's basically, his head is being fully replaced. The ears, the neck, the collar, the hair. Of course, behind him, the entire set is CG as well. So that's, to me, the future of virtual production is some sort of mixture of these things. I did a higher res re-render of it so you can see the quality. But when I was sharing this with, the family, it's like it looks just like the original actor, right? And that's a pretty compelling and powerful thing. And it makes you wonder. Now, granted, I do think that it's terrible to put in a prompt and get back a performance. I think the fact that there's a person that's driving it, there's an artist doing it, means everything. Like, I don't think replacing the artist or an actor is what we want out of this. And God help us if that happens, then you're going to have to think beyond the Turing test, right? That means that you have if you're going to trust an AI to tell us a story and to effectively live as a human and have that same authenticity, then you're in a whole other level. And that's kind of where the Star Trek story went, right? There's a character called Decker, and he falls in love with a replica of his lover. She's a machine, and he effectively decides, the machine is living. I'm gonna be with her, and that's the kind of thing that we might face philosophically, going down this path. Practically speaking, since we're in the business of scanning faces and actors and all these things, we want to make sure that gets handled correctly. Now, we do have a partner in William Morris Endeavor, Ari Emanuel, who runs it, has been one of my closest friends for 20 years. But all the people that we scan in, we go through them to, certainly if they're talent, to figure out how this ownership works. But it's still a mess. That's why one of the things that we're trying to do is figure out standards around this stuff. And we've also been scanning in heads, just 100 people here and there, and giving them royalties on the light stage heads that we sell through our subscriptions. And so SAG is also, it's interesting. It's interesting to see, of course, all this kerfuffle with SAG and the idea of does the actor own their likeness, and also what does AI mean? And I found this quote really interesting. It effectively is saying that if you have an actor and their face is being effectively replaced, it's like digital prosthetics, and that's exactly how our technology that I was just showing works. That, I think, is where we want to see AI and 3D face rendering go. I think that just arbitrary deepfake stuff is pretty bad. To that end, we've also announced a partnership just a few days ago between us, Endeavor, and Stability AI. I'm sure many of you know Stable Diffusion. Ahmad, who's the founder, joined our advisory board. And the goal of this is to figure out where these things all intersect, right? Stable Diffusion is probably one of the largest downloaded pieces of software out there. You have a million different things that are created with Stable Diffusion. And the training is transparent. You can see what's been thrown in there. It's like 5 billion images. But in order to do any sort of system around this where we can adapt and track what's going on, or somebody that's creating art or their face or their likeness is embedded in there, that's where the systems that we're trying to figure out need to come to fruition. We're also working with Stability on the problem I was mentioning earlier, which is how do you get AI to generate good 3D quality data? Do you generate a mesh? In this case, this is what SV3D is. It generates effectively a turntable, and from that it gives you a nerf, and then turns into a mesh. And the quality is not bad, but I mean, if you're an artist using it, we're far from being able to go and replace the stuff you get from a high quality mesh or model. And so that's where there's still a lot of work and research to be done. What's also interesting about the partnership with Stability is, I think, when I look at the ecosystem of things that are built around Stable Diffusion, especially with Comfy UI and all these other things, I mean, it's already a lot. And so what we want to do is we want to help figure out, once you get the training data to be done correctly and clean, could we then build a system where all these different GCCs can actually integrate with it in a more consistent way? Like, there's already a lot of great work out there, and I'm going to feature some of it, that takes Stable Diffusion and puts it into different 3D apps. But if we can come up with a way to make animation stable, all these other things work well, that'd be great. So people, again, another advisor in the company, longtime friend, great artist, gave me a wish list of things that he wanted to see, which is basically, I want my viewport to give me a filter, not to render the whole thing, but just give me a filter that I can then control and do it in a way that doesn't change every single frame. So these are AI renders. It's using Stable Diffusion. It's being sent data from our 3D renderer. It's not bad. You can get sort of repeatable things out of that. And obviously, is it Sora? Probably not, but it's definitely controllable, and that's important. Again, the other feature request is I just want to make it better button. Again, not changing the art workflow, but that's something that a lot of different artists are using, even if they're traditional 3D artists like Beeple. And so the kind of workflows that we're trying to figure out are things that are pretty well understood by artists already playing with this stuff. A Stable Diffusion node in USD or in our own ecosystem makes a lot of sense. I also want to focus on this tool, Kriya AI, which is based on Stable Diffusion 2.1. I mean, I'm taking my Octane rendered viewport and I'm sending it to this thing and I'm dropping it a photo and putting a scepter, and the baby gets the scepter, and it's like I can control it in my 3D scene, and it's pretty remarkable. This is just a very, very, very first taste of where all this goes. So if we, when we announced a partnership with Stable Diffusion, a lot of these developers were pretty excited because they're missing a lot of stuff. I mean, they're sort of out on their own in the wilderness trying to figure out how to bolt these things together. This is from Merck. He's an amazing C4D developer. Again, taking Stable Diffusion, putting it into Cinema 4D and creating all these wonderful effects. Put a lot of work into this, and we want to support that. But again, does it do animation? Not yet. There's work to be done. So if we can crack this with Stability and we can provide a pipeline where this can be done well, that's a big win. Blender, obviously, there's a Comfy UI for Blender, and this just was posted by a talented artist I think a week ago, showing all these different workflows where, of course, you can take a cryptomat pass and use that to sort of drive control net and get a bunch of interesting effects. It's not bad, but it's not necessarily production ready. There's, of course, Stable Diffusion for Houdini, Unreal, especially the pose stuff. If you look at the PoseNet the pose generator in ControlNet, pretty good stuff. On our side, deeper in our Octane engine, you're obviously looking at generating displacement maps that are correct. I mean, a lot of the stuff coming out of Stable Diffusion is, is a depth map normalized correctly, who knows. Also, feeding it into things like scatter nodes, being able to generate scenes is really pretty valuable. And I think that's kind of where the state of AI is. And I think with working with Stability and coming up with these different improved pipelines with our know-how and some of the work we've been doing, I mean, just even our work on faces, I think is very valuable and insightful. Ultimately, though, where do we go? Of course, the Vision Pro is out now, but the holodeck isn't that far. I mean, going back to that theme, Lightfield Lab, the company I was mentioning, they have those panels. Those are coming out next year in theme parks, location-based entertainment. So the rest of this decade, I see that slowly emerging as a really viable source of experiences. Now, granted, it'll be expensive. The first 4K Panasonic TV was like $150K, so this isn't going to be cheap. But eventually, it'll be in every screen. I mean, Samsung and LG, I think, are investors in Lightfield Lab, and course, you know, again, everyone's had experiences in VR and AR, but not having to wear glasses. I used to have to simulate this with a projector. Now I can at least do it in the Vision Pro. But there's just an entire world of opportunity from, you know, essentially glasses-free AR and VR. And I've seen, of course, our content running on the device. This is a video that was posted publicly. It's pretty remarkable. It's not an autostereoscopy device. It's blasting all those rays of light out there. It's really very demanding. I think it needs 16 A6000s to run. So it's not a device that's immediately running on one GPU, but eventually I think the idea is to put a single GPU behind every panel. I'm going to shift and talk about our work on rendering, GPU rendering. We've been doing this now for 15 years. Octane is continuing to evolve. I mean, we've been doing some great work, or at least I should say our artist community is doing some great work. I'm also very proud of the fact that separately from our own work with Paramount, the team over there was using Octane to re-render Star Trek: The Motion Picture, one of my favorite films. And it was even done on the blockchain, on our render network, our distributed GPU cloud, which is pretty wild. And I'll show you the content that's also being done by our team in Octane. So I don't know if we can maybe turn the lights down for this video, if it's possible. If not, hopefully you guys can see. That was our very first test with doing Spock, and it was scary. That was actually, I guess, filmed in 2022. So the Spock you saw was 2 years later, the one with the full CG head, and it's definitely, technology improving. But using Octane for that internally and pushing the envelope and mixing that with all these other tools was really very useful. Octane 2023, stable release, had some great features. We added analytic lights. Octane's been an unbiased renderer. We added analytic lights that can basically give you clean renders in one sample per pixel, which is useful. And we're trying to, again, keep Octane, sort of the unbiased, simple to use, fire and forget kind of system, while adding these kinds of improvements. And that's been, I think that's actually worked out pretty well. We're going to add, raise the limit for these analytic lights to 20. Added a bunch of post-processing effects. A lot of users wanted that, and of course GPUs are fast, so those look great. And those are all shipping in the current version of Octane, as well as, there's a lot of requests for very fast fog, and that's all done in sort of 2.5D, but it's all working in there as well. We've also added real-time motion blur and depth of field. Those are all effects that you can sort of turn on and off depending on how fast you want it, whether you want it real time, whether you want it to be absolutely path traced. But there's also a lot of speed ups we've gotten from ray tracing hardware. The current beta release of 2024 has a lot of improvements also to the post-processing node system, and also has the ability to denoise per lighting layer. A bunch of post-processing effects are possible. Really powerful shading system. You can use OSL inside of the post-processing stack. That's huge domain of creativity and productivity. Of course, a lot of users just want to have a list of shaders, so we're providing that. The other thing that we're about to put out this year, probably later this year, is we've per pixel displacement mapping that is real time. I mean, Octane's had this for a long time, but it's been you sort of had to fix or bake the textures. This allows you to just run shaders. I'll run it with an Octane, and it works pretty great. We've also built a new camera system. So the idea is that you can create really precise lenses that are pretty fast, and you can control them with physically correct diffraction, all those other elements. And I think those will be really useful for people that are looking at replicating exact physical lenses. We're all in on Material X USD. Obviously, that's basically a standard. So we're going to keep working on that, and that's going to ship this year. We put aside, we had a temporal denoiser that was part of our brigade. Brigade is mostly an Octane at this point, but the temporal denoiser was the last piece, and it was too slow on a 3090 and a 4090. So we had to spend 6 months re-optimizing it to get it to be at 30 to 60 frames a second. That'll be ready later this year. We've been showing this for a while, so this is not new stuff, but it is something that'll be shipping once we, with the performance features that we've implemented. And I think that real time is absolutely, you turn off shading and you can do 4K 60 with any complexity you want. Of course, the deltas in the scene or changes are probably, sort of a hiccup, but that's improving significantly with each generation. We've also, for the sake of having super fast renders, and those are useful when we're running, let's say, Octane on the Vision Pro, we can bake light fields, we can bake irradiance caches, and those things give you basically noise-free renders. Especially if you have harder ray tracing, it's pretty robust. So we can generate light field renders, we can run shaders that load them back in. And again, those are immensely useful when we're targeting volumetric things like the Vision Pro or light field displays that you don't want to have shading necessarily run unbiased full stop. So those are the pieces of tech that are in the sort of midterm for us this year. We've also spent a fair amount of time working on meshflets, which is basically nanite for ray tracing. There's a lot of research going on. We've been working on this for a while. It's basically twofold, right? There's the ability to load geometry, streaming geometry from disk. You could also stream it over the network, so you don't have to have any limitations in video memory. You can just pull stuff right off the disk, right off the SSD or the network if it's fast enough. It's taking a 40 gig scene and you're using a 300 megabyte buffer. And these things are designed to reduce the pain points for having limited VRAM. Even at a core is not great. And honestly, NVLink isn't in a lot of consumer cards anymore. So doubling your video memory by linking 2 of these cards, NVIDIA took that out. So we're looking at ways to just reclaim that memory footprint. And I think this will actually crack that open completely. It works for textures as well. So it's not just geometry, it's textures too. And I think that this is the kind of thing I was referring to, where if we have assets that are effectively unbounded and you can just load those in, that changes a lot of things. It changes things for games, of course, and Unreal is leading the way with that. Nanite does work in their path tracer as well, so it's not like we're necessarily the first ones to do this. But I do think for production rendering, this is a big deal. And certainly for us in our own projects and for the things our artists do, there's a lot there that we want to support. The other thing that we've built is, we just took the GPT store and we fed it everything that's Octane related, including OSL shaders, and we have Octane GPT. So within the help system, and even within the shader system, we can have an LLM just generate new shaders. As mentioned, the post-processing pipeline now has OSL code. This kind of stuff can give you the effects you want. I tried it with a Starfield shader, and it works pretty well. So LLMs is part of the pipeline for generating things that artists don't love, like shaders or code, or even complex node graphs. Very promising. We've been working with a bunch of partners to bring in other tools and software into what we provide, and also connect those things together, not just throw them into a bundle. So I mentioned we have Lightstage. A lot of the data that's going into that is sourced from people that come in, get paid, and we give them a royalty on their scans. With the machine learning stuff that I showed earlier, those can be animated, and we are going to be rolling that out as a service later this year. We have modeling tools like MOI, great animation tools like Cascadeur, which is an AI-based mocap tool, and utilities like Found that are great for asset retrieval. In order to also give people a single tool that actually is able to load a lot of these different pieces, we've rebuilt Octane Standalone. This is the new version. It includes, we license from Axon all of Cinema 4D, not the interface. Otherwise, that would be thwarting the intent. But it can load a C4D file, and it can use all those features. And those are things that can be used on the cloud. They can be used on, hopefully, an iPad, because this app will go out on the iPad and the Vision Pro. And we're looking to do something similar with Blender and Unreal, Modo, and others. So speaking of Modo, Octane is now bundled with Modo, which is great. So you get Modo 17. Octane is now the default renderer. We're planning to keep it that way for as long as we can. It's limited to one GPU, but frankly, if you have a 4090, that's equivalent of 8 GPUs from 4 generations back. So it's interesting to sort of see, we also integrate in Lightwave, and we have a lot of versions of Octane that are just effectively free to use. We've also contributed to the Blender Development Fund, because I see Blender as being this massive, untapped reservoir of talent, but it hasn't been commercialized. Todd came to me and is basically saying, let's partner up, let's do something together. And we are. In addition to sort of funding the fund, I want to build tools. I think that obviously the app cycles is great, Octane's great, but there's more. All the things that I've shown with AI, the ecosystem of services we have in the cloud, those are areas of serious interest. And also, when I gave my talk at the Blender conference, people were surprised that we're doing this much work, production work in Blender. But all of our Star Trek work, a lot of this content that we're doing is Blender-based. We have a whole bunch of different art teams. They use everything. There are artists that are creating stuff in Unreal, creating stuff in Cinema, creating stuff in Blender. But the Blender footprint is about half of our art team, and it surprises me. We had a bunch of Lightwave guys to switch to Blender. So I think that from even our own selfish perspective, I want to make sure that our workflow in Blender is great, but there's also millions of artists that could benefit from that. And I think that that's something that is just weird. We didn't think about this 5 years ago as Blender being this hyper-competitive DCC, but it is. Some of the pieces of tech that we're working on include, for example, live linking to Blender or Cinema 4D or Unreal, all with the same interface. We can do that remotely. We can do that probably in a more efficient way than a render delegate system. Unreal, we also, of course, have our plugins, Octane, all that in there. We use that for virtual production, also for rendering light fields and cinematic content. I do think that the render delegate system is very promising. We built that for Omniverse, for Solaris. Internally, we've built a scene delegate, so you can load in multiple render delegates. That compositing system I was mentioning, you can load Storm, you can load Octane, blend them together with a shader and OSL like I'm doing here. And that's also a workflow that I think is going to be more and more intriguing as Hydra evolves. Obviously, I'm pretty excited about Hydra too. And I mentioned before that a lot of what we want to bring to Blender users, for example, are cloud services. So one of those, probably one of the biggest ones that we're providing is rendering as a service. So we launched Render in 2017. It's decentralized. It has a blockchain token, pays out better than Ethereum, fraction of what Amazon or the public cloud providers have, and also has crazy scale, and it's crazy fast. So we have artists that have been using it for years, or even last week, like this guy, and it's life-changing. So the fact that you can do something decentralized and get a result that isn't possible with a centralized cloud or render farms is pretty remarkable. And I think that's something that we want to double down on. Obviously, there's a massive rush for compute and AI. No, these are not H100s or A100s, but there's a lot of AI stuff you can run on a 3090 or 4090 on inference, on training. Aside from that, we are doing renders for the Sphere on the render network, which is great. That thing is a 16K behemoth, right? So each frame is just a 256 megapixel monstrosity. The render network handles that pretty easily, and that's very rewarding to see. MSG is actually an investor in OTOY a ways back. NASA uses it. There's a lot of these great case studies. These have all been published already. If you're interested in sort of seeing that, please visit the site, and rendernetwork.com has a lot more information. And it doesn't matter what 3D tool you're using. We're supporting all of them. So it's not just Octane. We're bringing in other renderers. We've actually had a pretty good year. So I want to talk about sort of the things that we've done with Render. It is not actually run by OTOY. There is a foundation now that is totally separate from us. We still have a lot of voting power in the system, but we usually abstain. So it is run by the community, and that's different for me. I'm used to running my own company for 20 years, but it's actually worked out very well. And the foundation's up and running. It's served the interests of the community extremely well. We've also leveraged this system now to bring in pretty much anybody that wants to build an AI decentralized compute service. They can do that on top of Render. So we started to open that up last year for large language models, anything you want to do, right? And so now there's 4 different compute clients on Render, 2 more coming in. One of them, IONET, is already launched. They were the first. And they're bringing actually a lot of A100s and H100s, and we're providing our swarm of 3090s and 4090s. Beam is another one. And as far as ecosystem tools go, as I said, we're bringing in other renderers, so also other 3D tools. You don't have to save everything as a USD or an ORBX. You can use Cinema 4D natively, and you can just upload that. That's leveraging the Maxon SDK that we got, which includes plugins, so we can load in things like Redshift, which is also in beta. We also moved to Solana. So Ethereum was, when we moved to that and then Polygon, it just proved to be slow and expensive and complicated. So moving to Solana, changing our entire model so that people can pay a price that is fixed for rendering, and there's other rewards that are, if you're effectively running a node, you get a piece of the whole system. That model is too complicated to go into one slide, but it works well. And I think we've achieved equilibrium with render in a way that I'm very proud of. And we're just beginning, because there's so much more to be done. Everything we're doing on the Vision Pro, anything anybody needs to do on the Vision Pro, immediately when you're going to panoramic renders or anything like the sphere, you're going to hit these kinds of bottlenecks. That's what basically made us go to render in the first place, because every time that anybody was doing a panorama, 10K panorama, Amazon would, you crunch through 2,000, 4,000 GPUs for a single customer, because those panoramas are pretty chunky. And we're doing that for the Star Trek thing. We're doing 16K panos. There's 70 of these for a minute each, 1,000 frames. It's a huge amount of work. And if it weren't for render, there'd be no way to do it on the public cloud, much less locally. So I think render's got this potential as spatial computing takes off, especially as the light field pieces that we're working on can be leveraged on things like the Vision Pro for the first time. A lot of value there. I know metaverse isn't the best word in the world to describe, sort of an open 3D internet, but that's sort of what we've sort of settled on, and there are people that I think are working to reclaim it in a healthier way, like Neil Stevenson, who's a lovely person and get along with great. There's the Metaverse Standards Forum, which we're part of, but IDEA, the group that we started, and it's not that many of us, but Stability being part of that helps, is really meant for us to accelerate a lot of pieces that we can then bring back into these other standards organizations. So we can bring some of that knowledge back to Chronos for GLTF, MSF for USD and GLTF. We're also part of the open source USD at the Academy, and we're trying to contribute all the know-how we have, but we do have our own standard, which we need to run our own services, right? And it's not just for 3D file formats. And this is where the metaverse part comes in. Like, we have artists, we have creators, not just actors that are represented at WME, artists like Alex Ross or Beeple, where in Alex's case, we have his paintings, we're building 3D models, but documenting that and effectively creating an archive so that you have provenance, ground truth. God help you if you have any AI that steals Alex Ross's style. I have all his paintings, right? So there is a version, there is something on chain that describes that, and it works just as well for 3D models, and it works for stories, it works for narratives, it works for, if you ever go to a Wikibase page on fandom, you'll see that there's a million different links for every Marvel anything. It's insane. And that kind of fundamental data structure mixed with the 3D assets that we're building slowly for a lot of these properties, and others are as well, I think is an interesting and compelling use case for a standard in of itself. I mean, separately from the USD or the 3D mesh file format, what is the actual Platonic notation for an asset or a creator or an entity? And I think that's what's interesting. Obviously, in the case of Beeple, his work is his own thing. He's built physical pieces, he's built digital pieces. He does one every day. That's obviously one of his big things. But he's also trying to promote a workflow where other artists can use tools like Octane and AI, right, to generate everydays, to learn how to do art the way he does. And I think there's validity to that. You don't have to do it this way, but speed art is a whole style that he's not just pioneered for himself, but he has a whole studio, a fellowship. I'm going to be speaking at his event on the 4th, where you basically just have to do something in a certain amount of time, and that's it. And it's something that obviously he's been doing for 12 years, but it's a really interesting system that only is possible by the advances in GPU rendering. And maybe now with AI, we're going to see a whole other type of artist that can generate quickly beautiful work and meaningful work, right? The biggest archive of all, as I was mentioning earlier, is the Gene Roddenberry archive. My best friend's dad was Gene Roddenberry. I've been working on this with him for 20 years. About 3 years ago, we started to take this much more seriously, and we started to build real digital models of all of the sets and the ships and everything. And of course, we have documents, all the documentation of every script Gene wrote, every version of Captain Pike is in Return of the Archons. We have that. All the 6 versions before the cage. It's all there. They're scripts or documents. But what was interesting was we have a 3D art team. Let's see if we can build not just the Enterprise from the show, but also the ones that are in the physical space, right? Like the 11-foot model in the museum in the Smithsonian and the 1,000-foot model. So we've been building digital doubles of, we started with the Enterprise about 3 years ago, and it's beautiful. And this is the motion picture Enterprise. All the interiors are being done deck by deck, and we're about 40% of the way done. We'll be done with probably in about 3 years, and you'll have a physical, perfect digital double of the Enterprise, and then you'll have to have the stories that are told with that, right, play out. So it'll be something that truly will be a remarkable, almost, I think, dramatic experience in the sense of if you experience the world of Star Trek, where everything from, I mean, Jensen was showing Earth 2, right, where he's simulating the weather, but we do have a full solar system. Everything's procedural, and it's designed to basically be rendered for an episode of Star Trek, either from the script or from the novels or the comics, because a lot of those things never got filmed. Even work from Gene's scripts in the motion picture, there are pieces that didn't get filmed that we can now bring to life and do that spatially. So you can look around these things. I mean, that's a dream come true for a Star Trek fan. I happen to be a Star Trek fan, so I can speak to that. And if your favorite ship happens to be this one, that's great. And you can see the sounds, audio, interactivity, it's all there. If you go to roddenberry.x.io, you can play with all of this, by the way. It's live, and it's been live now for about a month. It's also on the Vision Pro. But if you happen to like the other Enterprises, Star Trek 2, Star Trek 3, it's all there. And it's the work that's being done is really, I think, a gold standard for how I think archiving and digital provenance should work for not just one piece or one artist, but for an entire franchise. And Star Trek is probably more than a franchise. It has a lot of meaning to a lot of people, so it's precious, right? And we take that very seriously. The people that are working on this project, Michael Dean Sakuda, I mean, they wrote the Star Trek Encyclopedia. They worked with Gene for 30 years. They've been involved in the creation of Star Trek. Most of these bridges are designed by them. So it's kind of this full circle. And yes, there are 14 Enterprises. There's 800 hours of Star Trek. Obviously, a lot of people love Patrick Stewart as Captain Picard. Well, that Enterprise is being built completely, killed to a bridge as well. And the E and the F. There's every version of the Enterprise is being built, and now we've started to expand to all the other ships, all the other worlds. There's hours of content now that you can try out on that website, and all of what you're seeing here is just a video, but you can actually go experience this live right now. And it's streaming from the cloud on NVIDIA GPUs, both to the Vision Pro and to a website. And there's other parts of it as well. I mean, a big part of this is not just this spectacle of visiting the show and having this quiescent documentation for it. It's also seeing the people that participated in Star Trek give interviews, like William Shatner, who we had an amazing 2-hour interview with. And when we put this out there, we did get a lot of attention. I mean, the Smithsonian actually ended up writing a piece about it. This is the web portal, an early version of it that you can go and try out on roddenberry.x.io. And we have all the ships, all the Enterprises, all the planets. We did put out more content. So I think you've seen one of the pieces that we did in 2022. We put out a piece last year that got millions of views, and I'll play it for you shortly. But the reaction was so compelling that we took a year to figure out what we want to do next. But certainly with Paramount sort of backing what we're doing now and building a relationship with us to put this out for Vision Pro and for the web, there is definitely an interest in doing short-form content that can leverage all this technology. So let me play the clip that we put out last year. It was just a 2-minute piece that was meant to bookend William Shatner's interview. Here you go. You guys like that. I have one more minute. I'll quickly wrap up. What you just saw on Vision Pro, trying to render that spatially is a challenge. We're working on it. We have, as I mentioned, this light field tech that is one approach. You can see it on there. It's running in Octane. And here it is running on the Vision Pro, 90 frames a second, 4K stereo, as a baked asset. So this, I think, I mean, this entire project is certainly a challenge, but especially bringing it spatially to the Vision Pro is probably our very first step to figuring out how we're going to do this for true light field displays. And of course, we have a full app on the Vision Pro. If you have one, you can try it out and download it and even play with those light fields. Yeah, and I think that as we look towards where this goes, I mean, being able to visit the enterprise, these are, by the way, metahumans. We have Unreal artists that love this stuff. Bringing your avatar in and seeing that world play out is going to be pretty great. It's a preview of what we're working on next. And with that, I will wrap it up. Thank you so much, everyone.